All right. I think I am live. Can you hear me? Can you hear me now? So you say, double checking some settings here. Had some mic issues before. All right. I think I'm good. Let's get into it. The tech stuff. It's not the camera, it's the microphone, right? Like, gets you every time. But things can be simple, like MVCC. That's what I'm saying. That's not too much to ask. All right. Let's get into it. Welcome back to the channel. Uh, Figured I would do another one of these. I put some questions out. I thought these look straightforward, but I'm sure I can complicate them. I sort of feel like so any good engineer is going to answer so many questions, if not all questions, with some version of like it depends, right? Like that's I think that's the nature of the game that we play. But then it's even worse if you are in the consulting field, right? Because then the it's depend can it really makes a difference. If you want to make it seem more complicated, if you have a solution, so I suppose it's not necessarily just consulting, right? Whatever your solution is that you sell to people, I think you can make it more complicated if you need to. But part of that also is just like I think I'll cut the consultants maybe more of a break than the product people, in the sense that if you are doing this as a consultant, you should be sort of an expert in the field, which takes you back to being like, that sort of senior engineer. Like you've seen the trade offs and you understand them. So that it just ends up being that way, right? Like, so then all answers end up being it depends answers. So it's true with a lot of things in life, though. That's just not tech. In any case, so pull some questions up. I think these will be straightforward. I'll give you some trade offs or whatever as I go through because, I'm going to do that. And then we'll do some bits and bobs at the end, and hopefully we'll all be good. So, all right, let me start with question number one. Can you add data to a Postgres database at runtime from the keyboard? I think this is a straightforward question, and the answer to that is sure, of course you can. You use something like PSQL, and that would be from the command line, and you connect to your database, and you can write insert commands and do all that kind of stuff. I did think maybe it's possible maybe that's not what they're asking. If you're thinking something more like Access, and there's a little bit of a difference here in that if you use like Access database in the past, Access basically is a combination of sort of the GUI and the database engine into one thing. And so when you access for 99% of people, they're probably doing it through the GUI and then they're just typing data in with a keyboard and you don't have to connect and do insert statements or whatever. You just type stuff in. If that's what you mean, then like you'd need a GUI that sort of supported that same thing. And PSQL isn't the way you would do that. But otherwise, like if you just want to do it from the keyboard, yeah, you can use PSQL and type in SQL statements. That will work. So just that's one way to do it. Yeah. So I'm assuming that's what you mean, and that's the answer. So there you go. Okay, let's go. Question number two. I'm gonna attempt to keep these sweet and short. Question number two: how do you see all the stored procedures for a Postgres database? So the sort of the basic version of this answer is going to be to look in a system table called pgproc, pg underscore proc, and you'll get a list of all the stored procedures in there. Now, I'm using the term stored procedure loosely, so we're going to intermingle functions and stored procedures. And one of the particular issues with pgproc is that it mixes all the system functions with all user functions. You can filter it if you look in the docs. There's a bunch of different columns in there. Primarily, I think like the schema and the function owner are the two that you're going to want to filter on if you're doing a SQL query. Just be aware that like if it's not actually schema, right? It's like the OID to PG namespace for the OID of the particular schema name. So you may have to do some SQL joins or whatever to get that information, and you could do that. Which would bring me sort of to the part two of this, which would be if you have PSQL, the aforementioned, and you use PSQL-E, if I remember correctly, is the flag that will actually show you the output of the queries that PSQL uses to get its information. So then you can use the backslash commands in PSQL. Backslash df is probably the first one I start with, which will list all the functions. There are other things like backslash df capital S if you want to see the system functions, that kind of stuff. So you can look at it that way and then see the queries that it's emitting, because they are going to do join. Like PSQL does joins to get some of the other information, right? Because it wants to show you like sort of the pretty schema name, not the like OID of the schema. So that would be sort of the second way to get it. Otherwise, like any good GUI tool probably should be able to list all these out for you if you're using like dbeaver or whatever, right? Like they'll be able to show you those. So so that would be how you list all the store procedures for a Postgres database. Question number 3. How do you determine the size on disk? How do you determine the size on disk all tables are consuming in a PostgreSQL database? So the shortest answer is go look up PG table size in the docs. And then let me complicate it for you. So I'm kind of assuming you don't want PG database size, which is another similar system function. There's a bunch of these different system functions in the system. And there's PG database size, which gives the total size of the database, but that will include things like index size. I don't know that you want that for PG table. For when you say disk, all tables are consuming in a Postgres database. I don't know if you want indexes with that or not, based on the question. I also don't know. So in Postgres, the way you store table data, right? 99% of your table data is the actual data that users are sticking into the system, right? Like you take that and you write it out into a file or possible multiple files, all of that user data. But there are a couple of other files that are put in place for every table where it's like the vacuum map for the table and a couple of things. So these are called relation forks. And there's a function called PG relation size, which will allow you to look up those individual sort of metadata files that are created for each table. And even a PG total relation size, I believe, which is the one that will sort of add those. I think there's 4 different ones, if I remember correctly. Maybe they've added another one. 17? I don't think so. So I think there's 4 different ones, including the heap. So you can look up the individual components, but I think you probably just want PG table size, and then that will give you for a table. And if you want to know all tables, and you use SQL query probably against the information schema, all the tables in there, but you could do it against a system table like PG class. PG stat, like user tables, might be more friendly as to pre-filtering the things that you want. Again, it also does like with all tables, do you also want the system tables like PG class and those ones in there, in which case go do it that way. So you would just select PG table size across every row in right in like PG stat all tables or something against the table name. Just do that and sum it all up, and that would give you everything. You can also get individual index sizes, so if you do want that as well. But again, if you're looking at the docs, PG table size is the function I would start with. And then it does break down sort of what are some of these other things that I'm mentioning here about relation forks and all that, and see if you need to fine tune the answer you're trying to get. I would say also be aware that all these functions are doing are basically like going out to the operating system and looking at stuff. So they don't have any knowledge of like, dead tuples and bloat or whatever that's in a table and that kind of a thing. So, just, I guess, again, be aware of that. If you're trying to find that kind of information, specifically about like actually useful data, you'll have to, do probably, well, I would say do some Googling on the bloat queries. There's a few different ways to do that. And that might get you something else. But if you want to know, like, how much is the data on disk actually being like, from this point of view, PG table size, best place to start, probably gives you the answer you want, no matter how much I try to complicate that for you. So, okay, let's go. Question number 4. We're moving through it quickly today. Question number 4, how do I enable remote access to a Postgres database server? So in my mind, there's kind of 3 things that I guess I would say look at for this. And the first one is going to be you need to have a role that has login for, and can connect to a database. So it needs an actual useful role that's there. If you have that, or once you have that, then the next thing you do is you go look in pghpa.conf, which is a file on the file system, which controls who can connect to which databases and from what addresses they can connect from. So go ahead, and that's really the main place where most of this work, quote unquote, tends to be. But that's where you would want to look next to make sure that user can actually connect to a database and using the right authentication methods and whatever. And then just the third thing I'm going to toss in there, which is look at the listen addresses config option in the PostgreSQL.conf and make sure that that actually is listening on some kind of interface that is remote. I think a lot of ones, I can't remember if Debian, I think it just configures you. Maybe it does give you localhost. As I say, look, I think some of these, like when you install from a package, it may only listen on like a local Unix socket, and that's a little bit more secure, like out of the box. But so that means if you're going to come from a remote server, you've got to be able to actually make a network path all the way to the database. And so you need to update listen addresses to listen on the NIC or NICs that might be involved. And I think for most people, they're like, well, most people just have the one NIC on a box. And so like it's got an IP address on your machine and and so you can just listen to that or whatever. Most people just say star, listen across all NICs. You may have like a specific NIC that goes out to a remote location. So you need to listen specifically, like on that address or something along those lines. So that's like assuming you can actually get to the box. And so when then, you say like, how do you enable remote access? From the Postgres point of view, it's only like, I'm assuming you can get to the machine and get to the port I'm talking on. And if you can't, like, that's a different set of problems. It's not my problem. And that could be like a firewall on the box that you're running on the server that you're running on, or it could be a firewall on the host computer from where you're trying to connect from, or it could be a firewall in the network in the middle, some kind of DMZ. Maybe you're doing some kind of proxy thing where, I don't know, you're coming through some external connection that's like dropping, like if you're doing like SCP or whatever, right? It might be dropping like SSL, doing SSL termination. That's what I'm trying to say, somewhere in the middle. So there could be these other pieces in there that you may have to troubleshoot and figure out. The thing that I always say is like, if you're trying to do remote connectivity into the database, the way you sort of figure out like, is my problem the database or is my problem somewhere before the database, is you have to get access to the Postgres database logs. Hopefully they are set up in a way that is, I would say, correct, so that anything that's connecting in that's not getting connected correctly will generate an error in the Postgres logs. And if you don't see those errors in the Postgres logs, your problem is someplace beyond that. And it can be tricky because the error message you would get from like PSQL going over a network to a remote Postgres server, like the error message that the PSQL client give you is going to look very much like the same error message you would get in the Postgres log. But you would get it in both places if it's a Postgres problem. Right. And you only get it in the one place, like, oh, I can't see it on the Unix socket or whatever. Right. That error could mean you need to go configure listen addresses. Right. Because it's saying like, I've connected to this address and there's no Postgres listening there. There might not be a Postgres listening there. Right. And so you would have to go do it. But if you don't see a similar type of error, something that matches over in the Postgres log, it means it didn't actually make it to where Postgres was. So you just got to figure out which side of that, you're on. So. And again, you can further complicate it with certificates and stuff like that if you use different authentication methods. But that's the three basic pieces are: make sure you have a role that can connect, probably with some kind of password setup or whatever, but and then look in pghpa.conf, and then also listen addresses just on the off chance that that's not configured correctly. So, all right, that is question number 4. So let us do question number 5, and we're going to actually do 6 questions today. I know I do 5. Then tomorrow I do 5. We're gonna do 6 today. But here's question number 5. How do you delete data from 2 tables in one query in Postgres? And this is a little bit tricky because there's no way. Well, I'm about to tell you a way that I think is in the SQL standard. I was about to say there's no way in the SQL standard to do this. I think there's no way in the SQL standard to do this using the delete statement, right? I think some databases do. I'm pretty sure MySQL has like a delete that can operate against multiple tables, and you join them together, and it's kind of weird. And it's weird in a way that's different from Postgres's delete that can use joins, because Postgres's delete only works on one table. I'm not sure if like SQL or Oracle or whatever have any kind of like special syntax like that, but the thing that MySQL does, it's spiffy, but also non-standard. So, but there is actually a way you can do this, and I'm sort of discounting. There are obviously other answers of like you could put 2 delete statements in a stored procedure and then call the stored procedure, and that would be one query technically. or things like you could put a trigger on the table and have delete from this one, delete over there, which would also include things like foreign keys, right? So I'm like sort of dismissing all that stuff. The way you can do this, and this is a little bit cowboy, but that's kind of how some people roll. You can do it in CTE, where you do like with X as delete from actor, comma with Y as delete from film actor, right? I'm thinking of Pagula schema in my head. Select one or something like that. That will actually, sort of nest those two deletes in that CTE. So you've technically used one query and you've deleted from two different tables. And we're going to ignore that there's a foreign key in there, but like that would work on two arbitrary tables. I sort of would say don't actually ever do that. Not for any particular reason. I just like it offends my sensibilities, I guess, in the way that when you're doing production troubleshooting and you have to like make up a solution is great, right? And then if you're like trying to be elegant about writing code or whatever, that's good Lord, I would hate to run across. If I ran across that, I'd be like, oh my God, what other surprises do I have in store for me in this code base? If I found a code base that was using that trick. Saying that, I have probably told developers to use that trick in the past. So, if any of you are out there, I'm sure you're going to call me out on that, but, yeah. So, but that's the way you can do it. It can be done. So, okay. It's sort of like a play on the old upsert trick, right? Of like doing an upstate or insert in the with clause or whatever. Like, let's not talk about that. Okay. So that was question number 5. We're doing 6 today because these are so straightforward, so simple. I try to make them complicated, but I don't know. I think they're pretty straightforward. But people got questions, right? Because not everybody knows, and maybe there's a trade-off in there. This one actually is a little more philosophical, so I'll try not to pontificate too much. Is structured or semi-structured data more appropriate for logging user activity and reporting? Okay, so I sort of am going to think about this question. This is a little bit philosophical, and the reason why is I think you have to think of if we're just storing logs, right? If we're just storing logs, and you're not going to look at them. Like to me, one, I don't actually think it matters, but two, I guess maybe you would count this as like semi-structured would be like just like let's say it was a JSON file or something, right? Or CSV data or whatever. If it was JSON, just throw in a JSON B column, go home. And maybe if you want to pretend like you care, you could slap like a giant gin index over the whole thing. That would allow you to query it without having to do like super brute force. It wouldn't be like super performant. And that's where I get to so you said for logging user activity and reporting. And I think the main sort of overall fallacy, I think that a lot of people have, and I think it comes from sort of relational purists who have good intention and are not entirely wrong with the idea that like if you have a set of data that you want to store, if you break that down and do normalization across the data, right, create different tables and define those relationships between those tables to model how your data is going to look. The theory is that when you then want to go do reporting on it, right, when you want to go query that data, it'll be in a format where you can easily manipulate the data and do interesting things with it. Not entirely wrong. There's other benefits, but I think that's a big part of it. I think the thing where people get tripped up on is, to me, how you store data is really more about what you want to do with the data than how the data comes to you, right? So if you are saying, I'm just storing like logging user activity, and I like the reporting, isn't anything particular. Like maybe there'll be some ad hoc queries or whatever, right? Like web logs are a thing, like Postgres logs are a thing, like just storing like big log lines on a text file. Not, now I'm going to also have to caveat, like when you say structured or semi-structured, I would say all of that data is when it's a logging type data, when it's log data, it's all has a structure, in the sense that like, which column. It's not like they put random columns in your log output, right? If you look at your Apache logs, like those columns are in a specific order. It's configurable, but they are in a specific order. So it has a structure. But taking that into account, like just storing all that stuff in text files, right? And then if you happen to like, I need to go grep on something, right? And then I'll like pipe it to unique or whatever. I'm going to do sec or odd, awk or sed. Yeah, that's what I meant to say. I'm going to do awk or sed on the data. And just again, you're just kind of brute forcing it. You could do the same thing on Postgres, and I'd like throw those JSONBs in there, slap a giant gin index, and come back and brute force it. I think it's a little more painful in Postgres because presuming uh, any of that kind of like logging type data is probably going to be fairly large enough that you might end up introducing toast stuff into the system. So then your brute force is like forcing Postgres to do a lot more work than like the standard text file would have to do. So it's not always pretty. If you know you're going to be doing reports, though, if you know, like, well, I'm going to be getting user activity data that includes IP addresses, and I want to do reporting on those IP addresses, I want to do reporting on those usernames, then I would say, like, go a little more hardcore in the picture. Like, can you pull that data out as it's coming in and map those to individual columns so that you can then do the reporting on it and make that reporting fast? But if nobody really cares, if it's going to be ad hoc, it's not like performance sensitive, right? Like, you might need to go get the data, but maybe not. And if it's just for you on an ad hoc thing where there's no time constraint, I don't think it really makes too much difference. And again, like it's logging user activity, like that kind of thing. Probably know what today is going to look like. If you know there's going to be a report, go ahead and do it. But it really is about, what's it going to look like on the other side? Because you could take that logging data, right? Like if you know, like, well, these are 10 fields I'm going to collect. I mean, you could build, 2 or 3 tables around that and spread it out or whatever. But it's like you're just kind of creating overhead for no actual benefit if you're not going to be reporting on it in some way that's going to make use of that data, right? Like, is it ad hoc? Is it specific, views or whatever? And so if you store it as JSON, like you can go back and add indexes later. You can make materialized views, maybe regular views, whatever it is. Right? You can always go build that stuff later. I would caution, like, don't over optimize ahead of time for a problem you may not actually even have. Right? You don't have to troubleshoot that problem now, so don't worry about it. Set yourself up. We got it in there. It's quick. It's sturdy. Whatever. We got some basic ability to go query it. But the query side is really what's more important in this question: is how are you going to do the reporting on it, as to how much like semi-structured versus structured is going to be more appropriate. So hopefully that is a useful answer. I know it's a little bit around the way here and there, but it's just because like there's certain definitions and certain things I think we do believe that I would say you have to challenge them at least a little bit to understand the trade-offs, right? I'm always about like got to understand the trade-offs. So, okay, speaking of trade-offs, I do have one bit and or bob. Not sure how you differentiate the difference between a bit and a bob. Just to wrap it up here, I wanted to let folks know I have not actually signed the paperwork, and I need to go like figure out the right thing. But I am planning to speak at the PASS Data Summit, which is in Seattle again this year. I spoke last year, November 4th through the 8th. Not exactly sure when I'm speaking or any of that stuff because, again, I have not done the requisite, like, yes, I'm going to go speak and do that. But I do believe I will be there and I will be speaking. So if you're going to go, that is the trade-off, is I'm going to go to Seattle in November, and it is cold there, certainly more so than Florida. But, I sacrifice for you, the people. Okay, so that's it for this one. If there are other conferences and whatnot, I will let you know in the future. I'm hopefully planning to go to one other one. If I know anyone at PGEU that can get me in that conference, planning to go to it, but we'll see. Otherwise, I will catch you here on the next episode. You can, of course, always follow me on Twitter, as I like to call it. I'm at RobTreat2 over there. I guess if you find me on LinkedIn, I don't know. I haven't posted much. LinkedIn is janky as a social network, but I am on there also. Otherwise, again, always like and subscribe. That's the thing, man. It's the thing. Help a brother out. Like and subscribe. All right, folks, that's it for me this time. I will catch you in the next one. Take care of yourselves, and if you can, take care of your database as well. See ya.